Hello students, a warm welcome to all of you at AriserTalent. How are you all? I hope you are doing absolutely fine. So, today we are going to discuss about some of the important questions that are from your topic, that resistance in series and parallel. This topic is very important. So, today we will do some of the numerical problems in resistance in series and resistance in parallel. So, let us move to the first question we have. So, this is our first question. Two resistances are connected in series as shown in the diagram. You have seen that these are the two resistances connected in the series, and we have to find the unknown value of R, unknown value of I. So, let's check what we have to find. What is the current through 5 ohm resistance? What is the current through R? What is the value of R and what is the value of V? So, firstly, I am writing here what I have to find. We have to find the current in 5 ohm resistance. This is the first question we have to find out. Second thing, current through R. Third part, value of R, and the fourth part, value of V. So, these are the conditions, that are the 4 questions we have to find out. So, let's move to the diagram again. Now, you have to find the current in the 5 ohm resistance. So, you can see that resistance is 5 ohm and the potential difference is 10 volt here. So, what I can write here for the first part, the resistance is 5 ohm and the potential difference we have provided is 10 volt. So, from Ohm's law, we can write that V equal to IR. So, I equal to V upon R. So, what it came out to be? It came out to be 10 upon 5, and 10 upon 5 will give you 2. And what is the unit of current here? The current has a unit of ampere. So, our first answer will be I equal to 2 ampere. So, this is the solution of our first part. Now, let us move to the second part we have, current through R. You have to calculate the current in this resistor. So, for this resistor, we have a voltage value that is 6 volt and the current that is passing here is 2 ampere. We have calculated the current is 2 ampere. So, let's begin the second part here. In second part, we have given a potential difference of 6 volt and the current here is 2 ampere. Now, we have to calculate the current through R. So, the current through R will be calculated by R equal to V upon I, and V upon I is equal to 6 upon 2 and it came out to be 3 ohm. Unit is very essential. If you are not putting any unit after any quantity, then how will you recognize that quantity? So, putting unit after measuring or after calculating any quantity is very essential. So, R came out to be 3 ohm here. So, R is equal to 3 ohm. So, this is the answer for our second part. But we have to calculate the current through R. So, we have calculated the resistance here. But if I have to calculate the current through this part, what I will do here, I have calculated the value of R equal to 3 ohm. Then I came out to be V upon R. V is 6 and this is 3. So, again the current will be 2 ampere here. Now, value of R we have calculated, the value of R came out to be 3 ohm. So, this is the solution of this part we have. Value of R equal to 3 ohm we have found out. Now, you have to find the value of V. Now, you have seen that this is a series combination of the circuit. 10 ohm and 6 ohm both are connected in the series, and what we will do in the series, we will just add the voltages here. So, for the fourth part, V equal to V1 plus V2. And what is the value of V1 here? V1 here is 10 volt and V2 here is 6 volt and it came out to be 16 volt. So, for the fourth part, we have an answer that is equal to 16 volt. So, these are the solutions of this problem which are completely based on the Ohm's law and the circuits are given in the series combination. So, you have seen that for the first part, we have found the answer that is 2 ampere. For the third part, we have the 3 ohm. For the fourth part, we have the 2 ampere again. And for this part, we have calculated that the total voltage will be 10 plus 6, that will give you the 16 volt. So, this is the solution for this problem. Now, copy this solution from here so we can proceed to our next part. Now, let's move to the next question in this sequence we have. This is our second part. Resistors R1, R2, R3, 5 ohm, 10 ohm and 30 ohm are connected in a parallel across a battery of 12 volt. So, firstly what you have to do? You have to draw the circuit diagram for this type of the question. So, let's draw the circuit diagram here. We have the 3 resistors. We have given 3 resistors here. Now, these 3 resistors are connected by a 12 volt battery. These are connected by the 12 volt battery here. We have the 3 resistances that is given in the question, that is R1, R2 and R3. And these are 5 ohm, 10 ohm and 30 ohm. And the battery is of 12 volt. Now, you have to calculate the current through each resistor. This is a parallel combination, so you know that we will calculate the current through each resistor just by simply dividing the same voltage across the 3 currents we have. So, the current in the first resistor will be I1, here the current is I2 and here the current is I3. Now, again applying the Ohm's law, we have V equal to IR and I came out to be V upon R, and we are doing the first part here. So, the first part is current through resistor 1. Current through resistor 1 and it is R1. It is I1 here. And I1 came out to be V upon R1. What is the value of V here? V is 12 here and R is 5 here. When you divide 12 by 5, it come out to be 2.4 ampere. Second is current through resistor 2. Current through resistor 2 is I2 and again it is V upon R2. What is the value of V? V is 12 volt and R2 is 10 ohm. 12 divided by 10 will give you 1.2 ampere. So, this is the current through resistor 2. Now, for the resistor 3, we will write current through R3 and it will be I3 equal to V upon R3. Again V is 12 volt and it is 30. Now solving this numerical, we will get 10 here, 4 here, 5 here and 2 here, and 2 upon 5 will give you 0.4 amperes. So you have seen that we have calculated the three values of the current because the three resistors are provided here, 2.4, 1.2 and 0.4. So the first part is having a three answers, that is 2.4 ampere, 1.2 ampere and 0.4 ampere. So these are the value of the current through each resistor. So we have calculated the current through each resistor. Now you have to calculate the total current in the circuit. So the total current in the circuit in case of the parallel combination will be the sum of all these currents. So let's begin the second part here. You have to calculate total current in the circuit. So the total current I in the circuit will be the sum of I1 plus I2 plus I3. So this will be our third solution. So the value of I1, I2, I3 is 2.4 plus 1.2 plus 0.4 and it came out to be 4 plus 2, 6, 6 plus 4, 10. So 0 here, 0.234, that is equal to 4 ampere we have. So the total current in the circuit is calculating as 4 ampere. Now you have to calculate the total circuit resistance. Now how do you calculate the total circuit resistance? You can see that these resistances are connected in the parallel, and in the parallel we do not add simply these resistances, we will do the reciprocal of these resistances. So the third part will be total circuit resistance. And total circuit resistance will be represented as 1 upon Rp. Why Rp? Because these resistances are connected in parallel here. 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, what is the value of R1, R2, R3? 5 ohm, 10 ohm or 30 ohm. So, I can write here 1 upon 5, 1 upon 10 plus 1 upon 30. On doing the LCM came out to be 30. Then it is equal to 6 into 1 plus 3 into 1 plus 1 into 1. 6 plus 3, 9, 9 plus 1, 10. 10 upon 30. 10 upon 30 is the value of 1 upon Rp. Then what I will get here? I will get here Rp equal to 30 by 10. So 30 by 10 give you 3. So it came out to be resistance in parallel equal to 3 ohm. So the value of Rp will be 3 ohm here. So you can see that when the resistances are connected in the parallel, you will just do the reciprocal of these resistances. So this is our solution of first part, this is our second part, and this will be the solution of our third part. So just copy this solution from here because these numerical problems are very, very important. Just copy it from here. Now, moving to the next question in this sequence we have. In the circuit diagram given below, so I am drawing this diagram again for you. So we have the diagram here, that is a battery connected here. This is a resistance, that is R1. Again we have a combination here, this is resistance and this is resistance. So the value of the battery here is 6 volt. This resistance is 8 ohm. This resistance is 12 ohm. And this resistance that is given here is 12 ohm again. So, this is our 7.2 ohm. So, this is the diagram we have given. Now, let's check what are the questions here that we have to find out the solution for this. Total resistance of the circuit, total current flowing in the circuit, and you have to calculate the potential drop across this R1. This is the R1 here. And these are our R2 and R3. This is R2 and this is R3. Now, you can see here, these two resistance are connected in parallel. These are parallel resistance. So, what I can do, I can simply calculate the value of parallel resistances here, and this parallel resistance will be coming across the series with the R1. So, first calculate the 1 upon Rp. 1 upon Rp, we can write here since R2 and R3 are parallel. Then 1 upon Rp will be equal to 1 upon R2 plus 1 upon R3, and it is equal to 1 upon 8 plus 1 upon 12. Now, 8 and 12 will have a LCM, that is equal to 24. It is 3 plus 2. It will be 5 upon 24 here. Now, Rp will be equal to 24 upon 5, and it came out to be 4.8 ampere. So, the value of Rp is 4.8 ampere. Now, if I am again going to draw that circuit, what I will get here, this is resistance R1, and this is, we have found the combination of parallel circuit here. So, this is the battery, and these are the two resistances simply connected here. So, you can see here, this is 7.2 ohm, and this combination of R2 and R3 is giving the resistance of 4.8 ohm. So, these are the resistances. Now, this R1 and Rp are connected in series. So, we can write here R1 and Rp are in series. What is the formula for series combination of the resistance? In series, the resistance are simply added. So, what we will get? We will get Rs equal to R1 plus Rp. And what it came out to be? It came out to be 7.2 plus 4.8. 7.2 plus 4.8 is equal to 12.0 ohm. So, what is the total resistance of the circuit? The total resistance of the circuit will be the sum of the parallel combination plus sum of the series combination. So, the first part is having an answer that is equal to 12 ohm. Now, you have to calculate the total current flowing in the circuit. Second part is total current flowing in the circuit. So, you have to calculate total current. Total current I will be equal to V upon R. This is the formula according to the Ohm's law. Now, I will be equal to, what is the value of voltage here? 6 volt. Battery is of 6 volt. And what is the resistance of the circuit? Resistance of the circuit came out to be 12 ohm. So, it is 12 here. So, I will be equal to 1 upon 2, and 1 upon 2 is equal to 0.5 ampere. So, again, this is the total current in the circuit. So, total current in the circuit came out to be 0.2 ampere. Now, what is the third part of the question saying? Third part, you have to calculate the potential difference across R1. You have to find the potential drop only for the individual resistor. So, third part is potential difference across R1. So, the potential difference will be V equal to IR1. Potential difference across R1, that is V equal to IR1. What is the value of I here? 0.5. And R1 here is 7.2 ohm. So 7.2 ohm. So point will be shifted here. Again 5, 1, 2, 2 will be cancelled by 72 by 36 times. So I will get here 36 upon 10 and 36 upon 10 will give you 3.6 volt because it is a potential drop. So what is the value of the third answer we are getting here? We are getting here 3.6 volt for the third part. So this is our third part, that is 3.6 volt. This is first part that I am getting here, that is series resistance 12 ohm and the current in the circuit is 0.5 ampere. So this is the solution of this problem. So you can see that if any of the complicated circuit is given, firstly you have to solve all the resistances so you can determine the value of the remaining part of the question. Now copy this from here so we can proceed to the next part. Now let's move to the next question we have. Now, three resistances are connected as shown in the diagram. So, these are the three resistances. What is the value of resistance here? This is our R1, 5 ohm. This is our R2, that is 10 ohm. And this is our R3, that is equal to 15 ohm. So, firstly what I am doing, I am just solving the resistances that are connected in series and parallel. So, what you are observing here, you can see that these two resistances are again connected in parallel and this combination is in series with this part. So, first solving this resistances. So, I can write here R2 and R3 are connected in parallel. If these two resistances are connected in parallel, what I can write here? I can write here 1 upon Rp is equal to 1 upon R2 plus 1 upon R3 and it came out to be 1 upon 1 plus 1 upon 10 plus 1 upon 15 we have. What will be the LCM here? 30. Then it came out to be 3 plus 2. 1 upon Rp is equal to 5 upon 30. And what is the value of Rp here? Rp will be equal to 30 upon 5. And 30 upon 5 will be equal to 6 ohm. So, let us draw the circuit diagram again. You can see here, this is your 0.5 ohm. This is point A, 1 ampere current is flowing through it and this is our point B and we have found that it is a 6 ohm resistance and it must be connected to some sort of battery here. Now, this is the simplified circuit diagram after solving these equations and you can see that this part is our 5 ohm and this is the combination we are getting in parallel. Now, what you can see here, these two resistances are connected in series. For the series, we have a formula, that is, we can simply add the resistances. So, what will be the total resistance of the circuit? Total resistance will be equal to R1 plus Rp. This is the Rp we have found out here. R1 is 5 ohm. and Rp is 6 ohm and it came out to be 11 ohm. Now let's check what are the questions you have to find here. You have given a current of 1 ampere that is flowing in the wire. What is the current through other two resistors? What is the potential difference across AB and AC, and what is the total resistance of the circuit? So we have simplified our third part. So the third part is total resistance of circuit equal to 11 ohm. So this is our first answer. Now let us move to the first part of the question. What is the current through other two resistors? Now you can see that we have a series and parallel combinations both. So we can see that voltage will be same here. So I can write here V will be equal to I1 R1 equal to I2 R2, and we can also write that I1 upon I2 is equal to R2 upon R1. This is the equation we are getting from here. So we will see that current and resistance are showing the inverse variation here, that is I1 upon I2 will be equal to R2 upon R1. Now I1 upon I2 will give you have the value of resistances as 15 and 10. So it came out to be 15 upon 10 and it will give you 3 upon 2. So I can write here I1 upon I2 equal to 3 upon 2, or I1 equal to 3 upon 2 I2. So this is the value of I1 I am getting from here. Now let us move to the diagram again. You can see here that the current of 1 ampere is flowing in the circuit. It means the total current will be distributed in both the branches. So value of I1 plus I2 is 1 ampere here. So we can do like this here. I1 plus I2 equal to 1 ampere. So this is our equation number 1 and this is our equation number 2. I am solving the half part of the question here. So on solving both these equations, what we are getting? On solving, I am getting here I1 plus I2 equal to 1 ampere. Value of I1 is 3 upon 2 I2. It came out to be 5 upon 2 I2 equal to 1, and I2 will be equal to 2 upon 5, that is equal to 0.4 ampere. I2 came out to be 0.4 ampere on solving this equation. If I2 is 0.4, the value of I1 will be 0.6 ampere. So we can write that I1 plus I2 equal to 1 ampere. I1 we have to find out and I2 here we are getting is 0.4 ampere. So I1 came out to be 1 minus 0.4, that is equal to 0.6 ampere. So you can see that this is the value of I1 and this is the value of I2 I am getting here. So what we have got here, we have got the total resistance of the circuit, and what is the current through other two resistors we have calculated. One is 0.4 ampere and one is 0.6 ampere. So this is the second part we have done. Now I have to calculate the potential difference across AB and AC. So let's move to the diagram again. You have to calculate the potential difference of AB and again AC. So the potential difference of this AB will be this resistance multiplied by this current, and in this diagram you can see here that 10 ohm is coming between this part and the current we have calculated is 0.6 ampere here. So this must be multiplied by this part for getting the voltage. So let's do the second part of the question here. So the second part of the question I am doing here. So let's see here. Potential difference across AB. So it can be written as VAB and V equal to IR. I is 1 and R is 5, so the potential difference is 5 volt. Now, what is the potential difference across AC? You have to calculate this potential difference across AC. So, PAC will be, potential difference can be written as VAC, again it is equal to I2R2. Here the value of current is 0.6 and value of resistance is 10, so it came out to be 6 volt. So the answer second, that is the potential difference, is having a two parts, that is 5 volt and 6 volt. So it is 5 volt and this will be our 6 volt. So you can see that this question is bit different from the other parts, because in this you have to calculate the potential drop across the two individual points. So copy this solution from here so we can proceed to the next part. Now let's begin with the next question, and this is our last question of the combination of resistances we are doing. Now, let's see the last question we have. This is our last question. For the circuit diagram shown below, find the value of current flowing through 6 ohm resistor and potential difference across the 12 ohm resistors. Now, again you can see that these two resistances are connected in series. Again these are connected in series, and this combination will give you the parallel combination here. So firstly solve these equations here. So firstly I am giving it name R1, this is R2, this is R3 and this is our R4. So we can write here R1 is 6 ohm, R2 is 3 ohm, R3 is 12 ohm and R4 is 3 ohm. R1 and R2 is connected in series. So R1 and R2 are in series. So I can write it as R dash. R dash will be equal to R1 plus R2, and it came out to be 6 plus 3. 6 plus 3 and 6 plus 3 will give you 9 ohm. So R3 and R4 are again in series. So I can write here R3 and R4 in series. So on solving these two parts, I am writing it as R dash, and these two parts are known as R double dash. So we can write here R double dash equal to R3 plus R4. Now R3 plus R4, that is equal to 12 ohm plus 3 ohm. It is equal to 15 ohm you are getting here. So R3 plus R4 will give you 15 ohm and this is our 9 ohm. Now if I am again drawing the circuit, I can found that these two resistances are connected in parallel. So let's draw the circuit again. This is our 4 volt battery and these resistances came out to be like this. Now this is our R dash. R dash is 9 ohm and this is our R double dash. And what is the value of double dash here? double dash came out to be 15 ohm. This is our 9 ohm, this is our 15 ohm. And you can see that these two resistances are connected in parallel again. So what we can write here, R dash and R double dash are in parallel. Now for the parallel combination, again we have a formula 1 upon Rp equal to 1 upon R dash plus 1 upon R double dash. This is the formula we have. So it came out to be 1 upon 9 plus 1 upon 15. So I can write here 1 upon 9 plus 1 upon 15. And what will be the LCM here? 9 and 15 is having a LCM of 45. So it came out to be 5 and 15, 3 are 45 here, and it came out to be 8 upon 45. 9 5s are 45 and 15 3 are 45. So we will get 8 upon 45 here. Now I have to calculate the value of Rp, and it came out to be 45 upon 8. Now on solving this part, I can say that it came out to be 8 5 are 40. It came out to be 8 5 are 40, 8 6 are 48, and approximately 5.62 ampere. So this is our Rp, and we can say that it is the total resistance of the circuit. This is our total resistance, and the total resistance came out to be 5.62 ampere. Now what you have to calculate here? You have to calculate the current in this 6 ohm resistor. Current in this 6 ohm resistor. If I have to find out the current is in this 6 ohm resistance, the value of the current will be I equal to whatever. According to the Ohm's law, we will get I equal to V upon R. And what is the value of voltage here? Voltage here is 4 and resistance here is 6. So the first part will be I equal to V upon R, and the value of voltage here is 4 volt and resistance is 6. So it is 2, it is 3, and it came out to be approximately equal to 0.6 ampere. Now what is the second part saying? In second part, you have to calculate the potential drop across 12 ohm. This is our R3, and you have to calculate the potential drop in this circuit. So potential drop will be V equal to IR. What is the value of I here? The I will be calculated here as the I that we have calculated will came out to be from this formula that we have calculated. 1 upon, this is our R, and 1 upon 9 plus 1 upon 15 will give you the value of total resistance here, and from total resistance we can calculate the current in the circuit. Now let's move to the next question in this sequence we have. So our next question is this. For the circuit diagram shown in the following diagram, what is the value of current through 6 ohm resistor? So you have to calculate the value for this resistor, that is for the current, and potential difference across 12 ohm. So you have to calculate the V for this part. Now what you have seen in this circuit, you can see here the 6 and 3 ohm are connected in series, and 12 and 3 ohm are again connected in series. So what I can do here, I can write here value of V is 4 volt. This is given. R1 is 6 ohm, R2 is 3 ohm, R3 is 12 ohm, and R4 is 3 ohm. So we can write here this is R1, R2, this is our R3, and this is our R4. These are the 4 resistances given. You can see that 6 and 3 ohm are connected in series. So what I can write here, R1 and R2 are in series. So I can write it as R dash equal to R1 plus R2, and it came out to be 6 plus 3, that is equal to 9 ohm. Now you can see that in the second half part, the again 12 ohm and 3 ohm, that is R3 and R4, they are again connected in series. So I can write that R3 and R4 are connected in series. So it can be written as R double dash and it came out to be R3 plus R4. Now this R3 plus R4 will give you a value that is equal to 12 plus 3 and it came out to be 15 ohm. 15 ohm. So you can see that we have calculated the series for the part first and series combination for part 2. Now what you have to calculate here, you have to calculate the current through 6 ohm resistor. It means the current will go in the entire branch here. So I can write it as I1 and current in this branch I can write it as I2. Now current through 6 ohm resistor, that is our part 1. So we are calculating current through 1 ohm resistor. Now current through 1 ohm resistor, that is I, will be calculated as V upon R. So I will be equal to V upon R dash because this is the series combination we have provided here. So it came out to be voltage here is 4 volt, R dash here will be 9, so 4 upon 9 ampere, and on solving we will get 0.44 ampere. So current through 6 ohm resistor came out to be 0.44 ampere here. Now let's move to the next part we have. In the next part you have to calculate potential difference across 12 ohm. What you have to calculate? Potential difference across 12 ohm. So the potential drop across 12 ohm may be calculated as V equal to I2 into R3. So potential will be calculated as the value of the current is I2 and the resistance here is I3. What is the value of I2 I am getting here? We can get the value of I2 here by just simplifying the V upon R, and this will be again the total part of the current in the circuit. So let's find the value of I2 here first. The current in the second part will be calculated as V upon R double dash. Now what is the voltage here? Voltage here is 4 volt. So this is our 4 volt, and what is the value of R double dash I am getting here? It is 15 ohm. So I can write it as 4 upon 15 ampere. Now you have to calculate the potential drop across 12 ohm resistance. So it came out to be I2 into 12 because it is the current, that is I2, that is flowing in the second half part of the circuit, and you have to calculate the resistance of the 12 ohm. So I am multiplying it by 12. So it came out to be 4 upon 15 into 12. We can solve it. 4, it is 5. It will give you 16 upon 5. And 16 upon 5 will be approximately equal to 3.2 volt. So the potential drop we are getting across the 12 ohm resistance will be 3.2 volt. So this is the second part or the solution of this question. Just copy this solution from here because all these numericals are based on the different concepts we have. So these are some of the important questions from the resistance in series and resistance in parallel. Again I am repeating, this topic is very important. So go through each question very clearly, so it might be possible to clear this concept in your mind that how will we solve the complex connections we are provided here. So this lecture is over for today. We will deal with many more topics in our next lecture. Thank you so much and have a nice day.